President, U.S. Vice President Al Gore, petrostates and their political allies are doing everything they can to stop the world from making progress on climate change. Now, so that's the backdrop, and that should have us all worried. This has to change in getting these world conventions. On the hopeful side, here you have the host country president, President Lula from Brazil, and you might notice the Secretary General of the UN, Guterres, there, and they put a positive spin on this because the economies of the world, economies of energy, are making the changes. So even though you might have resistance with the old fossil fuels industry, you see the advancements, the investments in solar power and geothermal and in wind. Hopeful signs coming from Bill McKibben's recent books. 74% growth in electricity generated worldwide, wind, solar, green. This country is making those commitments too. I track what happens around the world, and what's happening in China is very much in line with this conversion, this transition to cleaner emissions. And once you have renewables generating electricity, then you can produce hydrogen and have much cleaner combustion fuels. So I'm going to start by sort of having you share, let's say, an imagination here. So say you were at a local hospital and you're the attending physician in the emergency ward, and Earth comes in with acute symptoms, chronic conditions, and it presents, it comes into the emergency room with all these malaises. So what would you do as a physician if you were trained in the medical field? You'd take vital signs. You'd check lung functions, various organ systems. So how are the lungs doing in the world? Well, up until a couple of years ago, we were making progress and slowing the degradation and loss of forest. In the last couple of years, that has been reversed. And so when you look at the loss of forest every single year, the size of Switzerland, you have an idea how big Switzerland is, that's how much forest we lose worldwide. And we just can't plant enough trees to make up for that in the short run. But coming out of the COPs meetings, there's a new financial mechanisms that will start to pay developing economies, pay them not to cut down their forest. So there would be some transfer of finances. You would check the temperatures, right? You've gone to the doctors. They take vital signs. They check your temperature. Well, look at the records. And we are experiencing some of the hottest years ever on record in the last couple of years. But look at the long-term record going back to tens of thousands of years. It's remarkable. I put an oval around this. The Earth's temperature has been relatively stable for 6,000 years. That's where cultures have developed. That's where civilization, that's where you can count on climate for your agriculture. You can design your buildings based on climate records. Right? That is so important to have the stability. But look at the last part of that curve. And you see that this last half of last century and the beginning of this century, you see that very dynamic up. No longer count on climate having the stability. Now think of all your vegetation having to adjust. We can put air conditioning in, but you can't have forests move. They have to adapt to these changes. And look, the implications already. We're seeing this in the news all the time. Roads are buckling because they're so hot. Metal is expanding and shutting down drawbridges and disrupting rail traffic. Intense precipitation is gouging out the stanchions and the footings of bridges because we never have seen 3, 4, 5 inches an hour coming down as we are now in many places. Tropical downpours in areas that never experienced tropical downpours. So those things have changed. Just to put a point on the Earth's temperature, these are I try to update this got up until October of what the world's temperatures annualized on it, and then monthly averages. And this goes back to 1880. The blues, the dark blues, you see a steady progression. But I wanted to point out, and sadly it's true for 25, as I saw in 23 and 24, that looks like a new paradigm. That's distinctly higher than what was coming in the early part of this century. So something I think has really shifted here that changes. Look at your experience with typhoons, right? You see the results and symptoms. You're having typhoons where you in seasons that you didn't have before, because the temperatures of the oceans are hot on the surface and they're hot deep. So you check the fluids, right? You do a blood sample and do workup what's in you see in markers for disease. You do urine samples to look for metabolites, right? How well is the patient doing? Patient Earth doing? And you check the fluids and you find out they're full of plastics. You see toxic algae blooms. You see chemicals that are widely dispersed in our water systems. So you'd have to say, how well is the Earth doing? Now, this is the gloomy part of my talk. I'm going to try to make it a little more hopeful, right, as I go through this. And I tried to update this, so I got October measurements. So at Mauna Loa Observatory, which is out in the Pacific Ocean on the big island of Hawaii, there's been measurements of CO2 and other things going back to the 50s. And you see the early part of this curve here from these measurements, all right, where, no one really thought much about this. It was going part per million per year, and then a part and a half per million, and then 2 parts per million, now to 3 parts per million. So over the course of our careers, yours and mine, the CO2 background levels measured in the northern hemisphere, but it's circulated throughout the atmosphere, has gone up about 100 parts. And what you got to know, this is an important greenhouse gas. And so the thing is that if you raise the temperature of a gas, the atmosphere, 1 degree, it can hold more vapor. It can be moist. You know that from living in Hong Kong. You know warmer weather, higher humidities. You know that. Well, if you do this systematically across the whole globe, that's energy being put into the atmosphere. That's energy that goes into typhoons, into hurricanes, into other severe storms. So that's the consequences. Very, very straightforward. We know it from physics. So there's lots of symptoms that we see. What worries me and worries me for my kids is what it means to your generation that I'm talking, the students that are in our classes, right? They will live and be professionally active well into this century. What does this mean for them? How do they think about the future? The University of Bath in the UK did this survey a couple of years ago, and I think it's so telling. 10,000 kids across 10 different countries, and 75% of these young respondents believed the future was frightening because of climate change. That changes an attitude of a generation. And so what are the consequences? It's a phenomenon that even psychiatrists are talking about. Pre-traumatic, not post, pre-traumatic stress syndrome. Eco-anxiety. Anxiety, fear, desperation, lethargy. Here are the consequences. The key is we've got to not let this be a malaise for all of us. We have to look at it as a call for action. We have to get a sense of purpose out of this. And that's what I've been doing. In my group is saying, enough of this. We're going to really start working on solutions. But these are some of the pictures that I put together. See how desperate these people are from these having your house burned down. This picture of the fire, I took that picture. I was in Santa Monica, California in January and watched the Palisade fire this is one day where it burned down this hillside. A couple thousand houses burned out. Our hotel filled up with people. that ran for their lives, grabbed their pets, and try and find places of shelter. What disruption and desperation. So we know cities are heating up. We know that the change is coming. This is US centric, and I'll show you some data from this part of the world. But we know we're going to expect more and more days over 100 degrees now Fahrenheit. What's that, around 39, 40, 38 centigrade or so? And just like that report from the University of Belém, these are my grandkids. These kids were born in the early 2000s, 2002 to 10. They're going to be, by 2080, 2090, if they're lucky, they'll still be alive. And so here I am as a grandparent now, knowing what I know from my science and my field. I said, what kind of world, when I go, will they have to endure? So that got us thinking about what can we do about this, right? We can do more scientific articles, right? We can publish more, sit on the shelf somewhere. Maybe it'll have an effect. But let me go through quickly some physiology. So each one of us is burning some fuel that we ingested early today or yet last night in the mitochondria of our cells. And you're sitting here, you're probably 100 watts per hour. You're a 100-watt light bulb, right? I'm walking around, maybe I'm 120, my metabolism. It's energy. And our core temperatures is 37 centigrade. And we got to dissipate that energy. We can exhale hotter air. We can radiate. Air can blow by us and cool our skin. We can sweat and bring moisture to the surface. And if you evaporate that moisture, you cool down the surface. So that's the way we get rid of heat from our body, and we have to. That core temperature cannot overheat. You know what severe temperatures would be, how dangerous they might be, and it cannot get too cold. So we have a beautiful designed body to deal with these kind of extremes. But some recent data shows that, the theoretical limit is to have the wet bulb temperature, WT, right here, at 35 at the surface. That's the limit. If you're at 35 at the surface, that gradient to get the heat out of your body is restricted, right? And you are in danger of heating the core. And then you have organ failure and have other problems. So how do you get to that wet bulb? But now new data is showing even young people at moderate exercise, it's not a wet bulb of 35, it's a wet bulb of 30. And you can get to that point if it's 40 degrees air temperature and 50% humidity, you're at that limit. You're at that wet bulb limit because the wet bulb gets at the enthalpy of the air. So even though these studies were done in chambers with young people, hey, we're working outdoors. We're exercising outdoors. We might have diabetes. We might have hypertension. Those young people don't represent the rest of us or all of us. So there's real serious issues here. So this paper came out a year ago, 2 years ago, in the Proceedings of the National Academy of Sciences. And what they did is took that new empirical evidence that it's roughly 30 degree wet bulb centigrade, and projected with climate models, if the Earth heats up 1.5, 2, 2.5, 3, 4 degrees, what's the implication for people's ability to tolerate extreme heat? And what you're seeing with the heat maps here of India and China, they did it for North America, South America, Europe, the whole world. Great paper, really important paper I found. It's saying that there will be times in our experiences, many hours per year, that it's dangerous to be outdoors. This is profound implication. This has a significance, the first time in human history, prolonged exposures to excessive moisture and heat. So here's a cartoon of a body, and what are the implications of overheating the core? Your heart rate goes up. You start to have body failures, stress on your kidneys. People with diabetes get real serious threat under heat stress. And you can get to that point at various degrees temperatures and humidities. So even though it might be 36, 38, 40, if you have the humidity 60, something 50, if it gets hotter, you have to have very low humidities. And that usually doesn't happen. So that's the seriousness of the problem. Now look at it from a city point of view. Look at this infrastructure all around us. Think of all the air conditioning dumping heat out into the atmosphere. Think of our cars going down the street and our buses putting heat into the. Think of the thermal mass of an urban area. So cities, we've known for a long time, cities are hot, hotter than their surrounding areas. And they stay hot at night, which has implications to sleep quality, cognitive function, as we've seen. And cities, and it's not uniform. This is studies done, NOAA and citizens. Citizens went around the city of Dallas, and they've done this in other places, measuring the temperature in all area of the city. We took that data and put it into quintiles by census tract, the level of unit of geographic populations, and showed for the city of Dallas that it can be 10 degrees, 15 degrees Fahrenheit, what's that, about 5 to 8 degrees centigrade, different across the city. So who's living in the hot parts of cities? It's usually low-income people. They don't have tree-lined streets and put up. So is this a solution? Well, it's certainly the solution wealthy countries have adopted, right? We have the money, we have the energy, we'll put the air conditioning in. But India, you saw those pictures in India, India has about 10% air conditioning. Can you imagine India going to 90% air conditioning and what the energy burden is going to be? They only can do it in the short run with coal. That's the implication, which then makes everything else worse, right? I say dark, stupid surfaces. We had maybe not so much here, you're dealing with more tropical environments, but cities across dark roads, dark rooftops. We didn't care about that, right? We weren't thinking about what the absorbed energy would be in our cities. Glazing. So this is a picture from Doha, from the country of Qatar. You were in this region recently, and look at the architectural form. So they used to have climate-sensitive architecture, thick walls, small windows, narrow passageways that were shaded. They're the modern petrostate. So the expression of modernity is to have the architectural form celebrating the wealth of the country, to build these beautiful structures. Fascinating. This must be an architect's delight to get a commission and to do something in the Middle East. So I show this little arrow. So these are pictures that you got, Jinseng Wang. But think of that as me, right? That little colored person and the thing. And we had a research project in the Middle East, and we were staying at a hotel at the beginning of that arrow, and they were picking us up to take us to our meetings at 8:30 in the morning. And I'd come out of the hotel with our group from the School of Design and School of Public Health. I said, how far are we going? Oh, it's right over there. You can see the building. This is the building we're going to, this one here, this tower. I said, well, I'm going to walk. He said, no, you don't want to walk. This is June now. No, you can't walk. I said, no, I want to see what the city feels like. So as I walked across the city, I'm thinking the sun is coming up in the west, not the east. What's going on? It's bouncing off all these glass. So I'm getting heated on both sides. I am overheated by the time I walk half an hour over to where our meetings are. And the building is being cooled at around 18 degrees centigrade. So now I'm shivering. So they're trying to throw these. So these are not walkable cities. They're not outdoor livable cities. All right. So this got us deep into thinking, well, what is it that we want to do? My research group at Harvard. They said, well, Luckily, we found a phenomenal group called the Smart Surface Coalition. We can change what cities look like. We can think about doing these things differently in a real deliberate way. And we can put the engineering and the science behind it. When you do these things that you see in this picture, what does it mean in terms of how cool the city can be? How much water, moisture, excessive rainfall it can manage without flooding streets and overflowing sewer systems and the whatnot. So these are low-tech solutions. These are not phenomenally difficult things. What is difficult is to implement them at a city level. So things like just white roofs, instead of having 90% of the heat from solar insulation end up in the city, you have 18% because it's bouncing off. You can change these reflective surfaces. Here's a membrane that I was testing for a company that started here in Hong Kong, I2 Cool. And I just compared it on a hot summer day with my infrared thermometer. Look how much cooling right there, side by side. So that inner tube, dark, like we use on dark roofs, this membrane, versus something that has ability to radiate and reflect heat, right? So this company is a company to watch, all right? Because they have studied how a desert ant deals with extreme temperatures. Biomimicry, looking at nature. How has nature solved these problems with the creatures that are all around us and the trees and flowers and grasses that are around us? Nature has had all those years and years and years to adjust, to understand, to adapt, to change to its situation. So they found that there's microhairs. So they're using nanoparticles embedded in materials. They can change the emissivity, the energy that comes out of that material. So it's not just reflection, not just the albedo, it's a radiative energy. So they enhance the infrared emissions of a product. And they can put it on windows, they can put it on buses, they can put it on roofs, and now they have textiles. They can put it into apparel. These are important solutions. So over here on this side, this would be me walking down the streets of Doha, right? So light coming down this way, bouncing down, hitting the surfaces back to me. Now there's new technologies that can redirect that energy, put it elsewhere. But you can't convert a city this big. That's new development. So that can't be the situation that can be adopted easily. So to the Smart Surface Coalition. So we actually, and this is a new modality for academics, for me in particular in our group, right? So we actually are working with cities. The mayors of these cities have signed an agreement to work with us. Their staff is interacting with us, working towards implementation, working through the cost, through the technicalities, through the benefit side. How do they sell it to the public? It's going to cost money to do this. Well, if you have savings downstream and you have health benefits, what do? So these are the cities that we're engaged with now. And the organization is phenomenal. So just a few academics, Columbia School of Public Health here. There's some Indian institutions, because there are some cities in India want to join this process. But we have engineering groups, we have Trust for Public Lands, we have Association of Mayors, American Public Health Association, Lung Association, Nation City Leagues, industrial, corporate partners. This is what SDG, Sustainable Development Goal 17, says we need partnerships. We need radical new formations of relationships, radical collaborations. And so what this group is doing, we're doing the mitigation technologies that are there. We're helping them to quantify the impacts. We quantify the health benefits from doing this, what it means to protect education systems and jobs and tourism. And we're trying to address the inequalities, like I showed you in Dallas. Some places are hotter than other places. All right, so how do we do that? So one of our purposes, my group, is to look at the health benefits. So if you do these things in the cities and do it to scale, you start to reduce that temperature profile, right? You don't have the extreme temperatures, you lower it a couple of degrees. Well, we know by these algorithms that we work on, we know that it has a decreased mortality and therefore it has health benefits. It also decreased illnesses and hospital admissions. So let me share some of the knowledge that we do have. So this, we can do it for different causes. This is all-cause mortality and looking at temperature increases. We've clustered cities in the Midwest, cities in the South, cities in the Northeast, and you look at this curve, for the South, there's penalties even on extreme cold days too. That's not so healthy to people. But if we pay attention to summer heat, you see increase of mortality with temperature. But if you look carefully and see that there's a time reference here, it was a much more steep slope, you know, in the 70s and 80s, if you look at mortality back then, until the introduction of air conditioning got so extensive that people have a way of protecting themselves. Now that's good for that point. There's other implications about work outdoors and other things. But you can, but right now, when you look to the future, it doesn't stop at 40 degrees centigrade. We'll have much hotter days. So it makes sense to start this process as soon as possible. And then if you look at the issues of work outdoors, there are well-established worker productivity curves that as the wet bulb temperature increases, your productivity decreases. And this comes from many studies of populations. And yet we depend on people that are working outdoors to gather our foods or police our services. Let me give you an example here. So we wanted to prove all the technology, all the methodology. And so we had made an arrangement to work with the chief development officer for the San Francisco airport. So what you're looking here is the image of the airport that is just south of San Francisco itself. It's up the coast, up the bay from San Jose. Big airport, big international airport. So you look at this airport on the far left side, you see all the dark surfaces. And you can look at the albedo. The albedo is how much of that energy from the solar energy is reflected, how much is absorbed. So if you have albedos of 2, or 0.2, 0.1, that means most of the energy goes into the surface, into the material. So you want to have that albedo go up. So that's where we are characterizing all the albedos here, showing where the temperatures are across this airport, doing heat transfer models at extremely detailed level and intense calculations to answer the question, what if? What if we took the 0.2 and made it a 0.29, made it a 0.33, made it a 0.7, not much, but increase the reflectivity, cooling those surfaces? What would be the implications for outdoor working around that airport? So we had a methodology for predicting temperature differences as a result of changing the reflectivity of surfaces. And then we'd go to the productivity curves and said, well, what do you gain? And so on the right side here, you see low, medium, high changes in albedo and what the implications are across the 3 shifts of workers, because the airport's open all day, 24 hours. Bottom line is, if you cool these areas, you can gain labor activity back. That's not even counting how many mistakes they might make with high temperatures. Put the bag on the wrong plane. Well, you don't want that. But this is just productivity. How much? So these come out to be big numbers if you look across all employees. So we have this methodology written up, published in the Proceedings of the National Academy. So we went to a high prestige journal to get the recognition that we thought this work deserved as a real example of an integrated process. Right. So I'm doing a time check. Thank you so much. So I told you, Lin Yang, my biggest problem is just telling stories and going on too long. So let me fast forward here. I don't like to. So we look at this in terms of schools and how much learning is lost if you have high temperatures and in schools. So, and a lot of schools are not air conditioned, particularly, and it's going to get hot. So that ends up being big dollars. So we took on a project about schools. So we went back to our city. That's the heat map for our city, Boston, located in all the schools. We did studies across all the schools, but we focused on case studies on a few. One of them is this high school, the oldest high school in the US. You saw when it got started. And we worked with Tsinghua, University of Hong Kong at the time, to ask the questions, take that roof and think of different ways of modifying that roof. White roof, green roofs, solar roofs. And he did the calculations of what it would mean to temperatures in the classroom and what it would mean to the energy budget of that school. And ended up saying, well, here's the choices you have. And then we can look at the costs. This is important information for the city. Judith Rodriguez, architect, looked at vegetation, look at the canopy. What if you change the canopy? Put more trees around the building. And she ran these programs called iTree that gives the calculations. CO2 savings, air pollution savings, water savings, energy savings. So with a modest change, you can get a lot more benefits. And then it's a matter of choosing the right species and tearing up the parking lot and putting it in the right places up in it. So this is a characterization of how you can look in depth. That's what these cities need. They need us to help them make these calculations and do the quantifications of the things. We looked at emergency services, and lo and behold, there are more police calls, more fire calls, more emergency dispatching when the temperature goes up. So that's a substantial burden on a municipal budget, a city budget, because of the requirements for these calls. We did the same kind of analysis in Phoenix and Dallas. Phoenix is a hot city, as you can imagine, in the Southwest. 1.6 million people. Turns out that over the time period that we studied, over 5,000 emergency calls for the police. What they did in Phoenix, they coded. Why were the police called? Nonviolence, violence, road problems, domestic violence, health problems. So we could look at those outcomes versus temperature. The top row is the same day, temperature the same day. The bottom is a lag effect. Temperature the previous day, does that have an effect on today? But the real action was on the top. So the temperature the same day. Overall, dispatching calls went up, more police services. They went up for violence and nonviolence, domestic and health. Now, we don't know the economics of this, but you can see distinct relationships. Other cities that we did some of this analysis, we saw traffic accidents go up with temperature. So this is impacts on society beyond just the health. So what's happening? Cities like Phoenix take it seriously. They're changing the albedo of their surfaces. They're coding their roadways. Just a couple of years ago, they did 100 miles of probably over 300 miles of urban roadways, parking lots. And look at, it's gray in color. Not a huge change, but enough to start to show changes in the surface temperatures and then air temperatures. All right, what do I want to get to? Let me do some fun things. So we worked on another project in Springfield, a small city in Massachusetts. We worked with landscape architects from the School of Design. And we had the concept is if you can repurpose a street to bring a forest back into the urban form. And so this is a real street in Springfield that we studied. You can see not too many trees along that urban curb, the road curb. This is what the architects envisioned, right? So we asked ourselves, did we ever ask whether the citizens wanted this or not? What would they like? Would they like it to look like that? So we said, well, let's figure out how to do this. So we used LiDAR systems to measure every surface up and down these roads. And along with our collaborators here, you can see the LiDAR system that takes visual and laser print images. So we could take one road segment. So here's this road segment as it was in 24. You know, you can see buildings, tall buildings, residential property on this side, and a few trees along the way. And then we said, well, what would the future look like? So digitally, we can create a future. So if you did nothing but let these trees grow, what would you get? What would it look like? If you put trees every 40 feet, if you put them every 20 feet, if you put them every 15 feet, what would that look like? Then you can fly down into this and get visualization of it. This is your art project, right? But how do you relate to this? So we went to Google Street Views, same street, but now we said, let's look at it from where a pedestrian, where a homeowner might experience this street. We created scenarios, just like I said. We even said, what would it look like in the wintertime? And then we invited the citizens. They said, oh yeah, I live there. I know this. Yeah, that's my street. They said, well, what do you feel about this? What do you think about this? What would your concerns be? So it was what we called a digital design charrette, interactive with the citizens. We learned a lot. And, you know, so you think you're academics and you can prescribe the right solution for people. They always had good ideas. Right? Then we worked with the developer in Bangkok that envisioned this new commercial residential property that she was building out, this company was building out in the heart of Bangkok. And 35% of that land is devoted to vegetation, creating the urban forest right there in their midst. And this has been celebrated landmark as this now has been built. And right at the north end of that property, oh, the one thing that Tippleborn said was just beautiful. This goes to her Buddhist beliefs. She goes, this foresta, to take care of the snakes, the birds, the insects, because they were there first. She would refuse to put pesticides to kill mosquitoes. So they really had a reverence for all life. And I think it's celebrated in this form. And we worked with this company, DTGO, which is the parent company of that development company, because they put their new headquarters in. And we said, you know, we know that nature is good for you outdoors, it's good for you indoors. And they built these forms, these some natural real vegetation and analogs. And then we measured the effects on the workers, on their well-being, their productivity. So let me set up, this is the last, I saw the note here, I'll finish up with this point. So back to this issue of doing the detailed micrometeorology, the real physics of how you predict what you might get if you change the canopy, change the surface. This is really hard work to do it, and it's expensive to do it. So this gets it, so instead of doing it this way, which our colleague Altostrada would do, we started working with Dr. Wong's doctoral student, Leah, and Judith Rodriguez on my staff to say, what if we see the heat? What if you really see it? And see it, the materials that give you that heat, right? We can do that with infrared. And the clever part, the real clever part is how they got together and say, all right, we're going to do it mathematically. We know the radiant forces here. We are going to put it into machine learning format. So we'll take visual pictures, we'll take infrared pictures, and they did this walking around Kowloon, right? All over this city, almost 800 pairs of pictures. And from that started to train a program to say, now predict what the temperatures will be, and then add in the comfort models to say what people will feel in these environments. And these models starting to work well. You got to fix them and tinker them, but you know the validation. You know what you want to get because you did the actual measurements. So you can tell how well it did. So here, this model of version 3 does really well. So does it work anywhere else? So Judith had done thousands of pictures in Spain because they were dealing with hot cities in Bilbao and in Madrid and Seville and Barcelona. So she went around photographing urban forms, and she did infrared. So now the next phase of this is to put these data together. And does that program trained in Hong Kong, does that work in Spain? Or does that work in Harbin or wherever else you're, Abu Dhabi, right? Or do you need city-specific data? The value of all this is that we can go back to planners now, and we say, if we change that surface, now, we don't have to calculate all the mathematics of this. We could have told Phoenix, if you change the albedo, this is what's going to happen, because we now can predict it. This has great power in the hands of urban planners, landscape architects, that we share a vision of where this can be used, a tool like this. So thank you. Here's the group of collaborators. And it really represents I like finishing this up by saying, here we are. And the fact that we have our graduates that are in positions of professorships in different parts of the world, but in particular here in China, and they still remain good friends and they remain good collaborators. We share students together. We share visions. We're online meeting like once a week, doing our Zoom meetings to track the progress. Where are we going to go with this work? But it's a great, great team to work with. And I'll tell you, it's the one thing that makes me feel that just maybe we can work this through to the rest of this century, that there are solutions at hand that can be implemented. So thank you very much.
Thank you very much, Jack, for a very inspiring talk. Now, I'd like to invite you to sit in the front. We'll have the Q&A period. Okay, everyone has a microphone in front of you. If you wanted to ask questions, just push the button, then you can talk. Any questions? Yes.
Pull the mic.
Okay. Just like to break the ice and put in a question for Professor Jack Spengler, Professor Yan Chen, and many other audience here. Always inspired to sit in your lecture after, I think, since decades of sort of learning and being inspired by you. My question, following up at the slightly disappointing COP30 meeting at Brazil, and drawing analogy from the African ants that you showed in one slide. So as a species, a Homo sapiens, do we have hopes of sort of intellectually or proactively respond to climate disruptions? Or do we are not that different from African ants? It took 300, 200 million years of evolution, trial and error, natural solution with no purposes, eventually to get it right. Which option do you think we as a species would ultimately end up with?
Well, if you look at the arc of the Earth and say that was one calendar year, we as Homo sapiens have been around for the last few seconds of the end of that year. So we're a young species, right? Trees have been around for, billions of years, right? And plants and reptiles have been, so they've learned to adapt to all these different changes in their ecosystems that have changed. So I've thought about this a lot, and I draw analogies to what other great change of consciousness has the Earth gone through, the populations, people, mankind. So remember that there were times, and it lasted centuries, that slavery was okay, right? And then late 1600s, 1700s, they said, this isn't right. And it took, a century or more to change the human consciousness, where you'd get these profound changes. Gender rights is another one. And that's not worldwide, right? So you look at these things that need to change in society. Colonialism, colonialism lasted 400 years. Now we have economic colonialism, so it hasn't really changed. But the thing is to get these changes, and climate change is very much this. The social consciousness has to change and say, this is one planet. This is a one-way experiment that we're doing to ourselves. We have to face the reality of it. Now, so that's the desperate part. History says it takes a long time, right? What can accelerate that? Knowledge can accelerate it. I mean, think of smoking, right? Now, think of how profound the changes in smoking habits have been, right, across the world. Well, that happened quickly, roughly, yeah. So where do I think climate change? So, and I think education's too slow. What do you have, a couple hundred, 1,000 year old, think of it. Education's too slow. So then I thought, how's this Gen Z's, where are they getting information? Right, from each other, for sure. Influencers on their phones, TikTok and whatever the prevailing thing is here. And so I joined TikTok and I got to know some of these influencers, brought them to Harvard. And I said, tell us, how can you be so effective in using this media to get messages out? We're not doing it right. So I remember Isaac Hernandez, smart kid, graduated from Berkeley, dedicated to be an eco-talk influencer. He said, I did this program, this little thing on plastics, the use of plastics in grocery stores. And I said, yeah, how did that go? 2.7 million viewers. I haven't taught 2.7 million students. See what I'm saying? We got to figure out how to do this better. And so I haven't done it yet. But if I had a big class, this is you got 300 in your class, you go, I don't want any more assignments. I want them to produce social messaging, produce it and get it up online and share it. And your grade will depend on how many likes you get. But factually good information. I know that something has to change the slowness of the thinking.
Any other questions? I got a couple of questions during the registration, and then also, this is being broadcast in live streaming. So there are also questions on the crowd. So the first question is, how reliable is the projection of a 2 degrees C rise in the global temperature? And could this be considered normal climate variability? And I remember that a while ago, the projection is 1.5 degrees is a crucial point. If you break the 1.5 degrees, so then we are in deep trouble. Now it's 2 degrees. Can we just continue increase this?
I would say we're in deep trouble. I mean, look at the intensities. This summer, fortunately, it didn't hit the mainland US, but we had 3 Category 5 storms. That hasn't happened very often, just 1 or 2 years. So we're into that change now. So, but if it's not like it's going to be one catastrophic, but those temperature curves clearly, to me, look like a departure from the steady rise. So.
Yeah, let's also bring you to the another related question. Because in the recent years, especially in the summer, right, the extremely high temperature frequency is increased a lot. So what do you think in 10 years in the same region, what will be the frequency changes? Will getting more and more becomes the daily life events or what?
Well, yeah, I think the projections and the records are following through. I mean, I experienced it growing up. You know, you experienced the Boston. We rarely would have a day in the 90s, rarely in the summer. We had 10, 20 of them now, right? So maybe, first of all, the geographical extent is going to change. So the climate that we're experiencing in Boston is now not quite, but will be like the climate of Virginia. There's an analogy that shifted, I think. The other thing you got to think of the physics here of the atmosphere is we're weakening the north-south temperature variations that drive the jet stream. So you heard the polar vortice, right? If that temperature incline shifts and weakens, there's more intrusion, there are more extremes, right? There's more tropical air getting north, there's more polar air getting south. There's more mixing because the zonal flows have been weakened. So that all goes to the physics of the atmosphere.
Yes.
Yeah.
Okay. There are two questions there. The one in the front first, and then we'll go back.
I'd like to ask a question.
Testing. Thank you, Professor Spengler. Thank you for your talk. My question would be, in general, do you think a certain amount of activism is necessary for promoting environmental awareness? You just mentioned an example of smoking, like the world take just several decades to ban smoking. I think the effect is quite good in North America, and but I think by activism, I meant in certain situations you need to stand up to say no to certain behaviors, thoughts. I think it takes a lot of courage to do that. If, for example, the one smoking is your friend, your parents, or even your boss, do you still have enough courage to say no to them? I think that's just so difficult. I also follow a lot of influencers, either on WeChat, Instagram, TikTok. There's one I found quite interesting. He's from UK, and he's doing an WeChat account in mainland China, and basically what he do every day is to say no to a person to either in a little restaurant smoking or in a cinema smoking, and he got a lot of threats by doing that. Yeah, I just want to learn from you, like what are your thoughts on this?
Let's draw an analogy to something that's closer in time, and that's COVID. So we had in the U.S. mandatory vaccinations, mandatory wearing a mask, and that sort of massive prohibition of forcing people to do something had this consequence. It started to be a political divide. And people got angry at each other, and it just so I think the prohibition I think we have to recognize it's going to be hard to change in some ways. Some things are relatively easy, but it's hard to change. I'd love to change my diet. I might try to do it for a while, and then I come back, go out and have a banquet. You're right back to your same sort of lifestyles. So I mean, it's hard to do it. So it's got to be leadership of our thought institutions, our academic institutions, to make it a livable experience while people are here on campus, and then by extension, other thought-leading companies have to really embrace this, and they are around the world. So we've got to make it more the norm rather than the no, right? But to your protest, to your activism question, so I I respect my daughter who feels this very deeply. And so she joined a group called the Extinction Rebellion. And they're formed out of the UK. And it is street performance, right? So there might be a fair, might be a gathering, and they go and they do something that dramatizes the concern about climate issues, or they protest the extension of an airport, fossil fuel use, and things like this. So they put their bodies on the line. And I've participated on some of those, and I have to feel like it's good for me personally, not just to have it all in my head, right? To do this lectures, to actually physically get involved, put something at stake. I think so I said, why should I be talking to others to do it when I'm not doing it myself? So I think you do what you can in the circumstances that they present, but there during the rise of the Greta effect, when there were massive environmental protests in Europe and the United States, and somehow we're so caught up with everything, all the other craziness that's going around, that isn't coming to the top of our concerns, but it should. But so I think it's a mixture. We have to dramatize it. There have to be people willing to do the activism to draw attention to it. Has to be. That's part of social change, right?
Thank you. And then the person behind. Yeah.
Good morning. Thank you, Doctor. This is a big topic. I can continue a little bit. I think we need support from the government for this at this scale. But at the same time, it seems that the priorities of the governments, they're different. When we talk about ESG, the ecology, environment, and the sustainability and governance. But now it seems like it's more, we talk about economy, the security and geopolitics. So how can we make it more, I would say, serious and severe on this case and these cases, and how can we tackle this problem?
I think this is a cyclic issue because it wasn't that long ago that I was working. I never thought as an academic I'd be working with a financial institution, UBS. Yeah. And with pension funds from the Netherlands to quantify the impact. They wanted their investments to do good. So we worked on ways of quantifying, if you invest in these companies, here's the benefits that they will derive for climate, for water, for health, for food, and things like that. So what I'm saying is that at that time, there was some of the leading institutions were making profound changes. We worked with the World Travel and Tourism Council. They understood that climate is a threat to their business. So when they make that connection, they said, listen, we're doing this, maybe the economic reason, but we're doing it because we have to do it. We want to do it because, they want their people to go. So I think that we're going to see, in fact, there's still pressure by some of the big, insurance underwriters, Swiss Re and others, to say, what's your climate risk? You want me to insure you, your property is what? What's your climate risk of your facilities? What are you doing about this? So it's still there, all right? But I think it's been more institutionalized. We don't see it as but you're very right. Contemporary thing is it's this geopolitical tension. It's I'll say the craziness that we're experiencing in our system, and it sort of throws you off, right? And but it'll come back. We can't ignore it. I mean, let me ask. I mean, what's your sense of hopefulness, right? Turn the question around. What do you think? What's your perspective?
For the best.
Yeah, hope for the best. Well, that's why I pointed out, I put it in my lecture. i2Cool company came out of Hong Kong, right? Using biomimicry learning from nature to create new solutions that are cost effective. So on one hand, our ability to face a crisis and invent a future. So my son, that's what he believes. Oh, humans will come up with something. My daughter's more spiritual, more artistic. Said, no, we got to change. You got to think about fundamentally changing structures within society, which I think it has to do.
Yes, please.
Dr. Spengler, okay, thank you so much for the inspiring presentation. I enjoyed very much. I count myself also as a climate scientist. I've been giving similar presentations everywhere. We even share the same slides, very similar slides.
Good.
But I'm a geophysicist, so I understand your focus mostly on local scale. How can we deal with, global climate change? Can you comment on, for the whole society, for the human being as a, in general, how can we deal with, climate change, global warming? I know, albedo, we try to deal with, how to reduce albedo, but if you consider on global scale, the ice melting, the sea ice melting, the snow cover reduction, that's a very small component regarding, the albedo. So in the global climate system, so we still have a big challenge, much bigger challenge in front of us.
You're absolutely right. There was an interesting report commissioned by Congress to the Biden administration, White House Office for Science and Technology. And they put out a report on solar management, right? They came out with technologies that will actually shade, you know them, put something in the stratosphere, put satellites
yeah.
up, increase cloud
Mhm.
cover reflection, right? And they did a credible job of what it would take to do this. The money wasn't crazy expensive compared to the damage. But we don't have governance. We don't have international agreements, right? To say, well, we got to cool the planet. It's not just taking a city and cool a city. We got to cool the planet.
Yeah.
Now, very large volcanoes do that, right? But can we create a human volcano in the sense? Can we create that? You know that part. So for those that don't, the idea is to put a reflective material, sulfur particles or something else, in the stratosphere, and they will spread out, and they will intercept the solar energy coming in only 1%, 2%, not much, but to cool it. It slowly settles out, it goes away, and you got to do it again. We have planes that can fly that high. We have materials that will work. We can do it. But can you ever get international governments to agree on what to do? The concern was pointed out in this report. There could be a rogue country that has the capability of doing it, and it's not that far from here, that says it's so bad and that I got to do it. I got to put this in my latitudes over my country. It'll spread out around the world, but I got to cool my country.
Okay.
That
will help.
Yeah.
If I think about the Earth's energy imbalance, it's just a few percent, less than a few percent. Yeah.
Yeah.
So if I can reduce 1 or 2% from the
that's
solar
right.
radiation, that's a big
Yeah.
improvement. Yeah.
But you have the deep green people, right? The eco people that said, this just lets us continue to use fossil fuels and do what we do. And we'll just go backstop and cool the planet a different way. So there are people that have a philosophical disagreement with this, right? My personal feeling is we're going to get to that point.
Good.
I don't know. What do you feel?
Okay. Yeah, I agree with you. Yeah, definitely. That's a right direction.
We're going to have to.
Yeah, we can go. Also, I noticed you use, Phoenix as an example. We all know Phoenix, is a very hard city, But I want to give you another fact. In Austin, it's also very hard. I remember in your slide, the record in Phoenix, something 70 days over 100 degrees. You know how many days in Austin was the record? I spent 28 years in Austin, Texas. It's 90
90
days
of 100.
over 100 degrees for 1 year.
Yeah.
So
How'd you feel?
it's real. Climate change is real. Yeah.
I was in Las Vegas at a meeting and we're going to go to lunch. And they said, well, let's run out, get in the car and drive. It was a couple blocks away, right? Same thing I did in Doha. I said, no, I like to walk. I go out, the heat was coming up at me, right? My feet were hot walking across it. Right? You know that from
Yeah, certainly. You know, each evening when I try to drive back home, you know, from parking lot, it's just in the car, you cannot get into it. It's just so hard. Yeah. You just couldn't get into the car.
I remember being in Doha, the street was sticky. The asphalt was so hot that you put your foot, you could feel it stick your feet.
Okay, thank you.
Yeah.
All right, that's another interesting questions here. They say the emerging technologies such as AIs are great for the society and bring the human being many benefits. But you know, AI now is using enormous amount of energy, which contribute to climate change and environment. On the other hand, many parts in the world, they are still lack of energy, electricity, etc. So the question here is, how do you balance between must have and nice to have, and also considering the climate change?
Yeah. So I know a little bit about this, enough to say something, whether it's reasonable or not, I don't not know. But currently, so where our data centers are going, they're going out in the Southwest and other areas. And you're right, they're very intense. But our utility structure is that all the ratepayers are paying. That's the thing that's inherently bad. So there ought to be a differential energy pricing to put the economic pressure. Either if you're going to use more, you're going to pollute more, you pay more, right? So in some ways, we got to come to grips with the fair, equitable carbon pricing. That would be, and I think that would start to put some signals to the market that you better do this with renewable energy, right? Or else you're going to have to pay the economic.
Okay, maybe we can entertain the last questions from the audience. Oh,
I want to have Mickey ask a question.
okay.
Yeah, your shirt says Mickey.
Thank you for your talk. Actually, I'm not I don't major in physics, so I'm gonna ask a kind of simple question about the title of this talk. So when you put this title, if you think it is hot now, just wait a few years. Do you mean that the climate and the temperature is gonna change for the better or worse? Or why do you say wait a few years in this title?
Yeah.
Thank you.
Because it's going to be hotter. That's what I would say. But you know, the physics is pretty clear. I mean, you think the sphere, the globe, and you put a gas above it, right? That's our atmosphere. Now you put things in that atmosphere that keep energy from going out into space. Those molecules actually heat up. They move. You're putting kinetic energy into molecules that are part of the air. So it's real sensible heat. So that's why if we keep this, the other great analogy, you're filling up a bathtub and the water's on and it's overflowing, right? The only way to do is get a bigger drain or turn off the water, right? So we're putting more and more into the atmosphere. And so the radiant balances are all in the direction of getting hotter unless we rapidly change the curve.
Okay, because we are running out of time. So thank you again, Jack, for your wonderful talk. We don't have an applause today because of
Yes.
the victims in the fire. So, but we do have a souvenir for you. I'd like to present to you as a memory for your wonderful lecture. So this is just with your name, the lecture titles on it. Okay, and I hope you will just remember this.
When you come and visit, I'll serve you some cheese.
Okay.
This.
All right, then I would like to thank all the audience here for your participation in today's seminar, and also especially for those asked questions who contribute to this seminar to be much more cheerful and then also meaningful. And Peer conduct the seminars, lectures from time to time. I'd like to invite you to pay attention to our announcement next time. And thank you again.